Hello guys, this is Mr. Brain, okay? I want us to look at hydrocarbons, okay, very carefully. So hydrocarbons is one of the topics that you are expected in chemistry. You are expected to prepare for it, okay? And hydrocarbon, organic chemistry, and organic compound, they are all intertwined. Alright, so now there are 10 questions behind me, and I strongly suggest that you pause the video, alright, to take note of all the 10 questions as I answer them now. So just pause the video now and take note of all the questions. Alright, now let's take the first question. The following are hydrocarbons except so hydrocarbons are compounds of hydrogen and carbon. Compounds of what? Hydrogen and carbon. So pentane is what? 5 carbon, you know that, and 12 hydrogen. Pent 5 carbon and 10 hydrogen. Pent 5 carbon and 8 hydrogen. So this one is pentanol. Pentanol means that the functional group there is hydrogen group, that is OH. Okay? So OH is not an hydrocarbon. This OH is not an hydrocarbon compound because from the definition we said hydrocarbons are compound of hydrogen and carbon. I hope you understand. Alright, so this is our answer here. This is not an hydrocarbon. Okay? So number 2, we have CXHY plus 5 oxygen gas give us what? 3 moles of what? CO2 plus 4 moles of water. Alright? Now, it says in the reaction above, the hydrocarbon CSHY is what? So, we are trying to find out what hydrocarbon is. What hydrocarbon is this? Okay? First of all, in order to solve this question, I need to clean this part of the board. Okay? So that I can solve this question. Alright? So, how many carbon is here? X. How many carbon is here? 3, right? So, our carbon, X is 3. How many hydrogen is here? Y. And how many hydrogen is here? 4 times 2. So, Y is what? 8. Can you see that? So, what formula or what homologous series does this conform to? Remember, every homologous series or every organic family, alright, they have a formula that they conform to. There's a general formula that every one of them conform to, okay? So what formula will this one conform to? Let's start with the first one. CnH2n plus 2. This is alkane family, the first family, alkane, okay? So when I put my 3 here, that will be C3 is 2 times 3, 2. You know, n is 3 now. If my n is equal to 3, now the 2 times 3, that will be what? 6 plus 2. That's 8. Can you see? So it has conformed to my, can you see that this conforms to my what? My, what do you call it? Formula. So this is an alkane family. Can you see? An alkane family. Alright, that is alkane, okay? So now let's wipe this part on the board so that we can answer the next one, please. So the next one. Heating of soda lime with CH2, COOH. We produce now, you see, the method for producing our alkane is when we heat soda lime with sodium ethanoate of the corresponding alkane, okay? So now this is sodium, sodium alkanoate of the corresponding alkane. Now this is sodium what? 1, 2, 3, 4. Sodium propanoate, okay? So when you heat this sodium propanoate with soda lime is a mixture of sodium hydroxide and limestone, okay? That mixture is combined because it prevents the cracking of the glass. If you use sodium hydroxide only, there will be a crack in the glass, okay? And there will be a sucking back of the gas during production. These are some of the questions you can see in what? In JAMB questions. So now, we will use soda lime, a mixture of soda lime, that is, remember, sodium hydroxide and what called quick lime, okay? So, if we use that, that will give us propane, okay? So, that will give us propane. So, imagine that we use sodium ethanol, that will give us ethane. So, no, sorry, this will give us butane, rather. If we use sodium ethanol, that will give us what? Ethane, right? If we use sodium methanol, that will give us methane. You see that? Alright, so we use a preparation of alkyl compound or alkyl family. Alright, we use the corresponding sodium alkaloids with what? Soda lime, okay? So now when we heat this, we are going to get, remember 1, 2, 3, 4, we're going to get butane. Alright, so when butane, this is the correct option, butane. Please take note, alright, I've explained some things already. Now, number 4, the reaction between alkane and the halogen is when alkane reacts with halogen, alkane, alright? Now, this is how to represent your alkane, okay? This R means alkane family plus H. This alkane is also having a general molecular formula of what? CnH2n. Okay, this R stands for CnH2n plus 1. So that one hydrogen is what you are seeing here now. So both this and this. This other one is for R, then you now have your hydrogen, okay? So the one hydrogen missing here, look at it here. So both this and this is a way of representing our alkane family. So now, it says alkane, the reaction between alkane and halogen. When alkane reacts with halogen, X is used to represent halogen. Halogen includes halogen, bromine, chlorine, and fluorine, okay? So the reaction between alkane and halogen will lead to what? Rx, alright? Then your hydrogen gas is like right there, okay? So if you balance this, you put 2 here, alright? And 2 there, and you have the 2 there, okay? So now, what kind of reaction is that? This reaction, you can see, this halogen went in to substitute this hydrogen. So that reaction is called a substitution reaction, okay? This is a substitution reaction because this halogen went in to go and replace hydrogen, okay? In a more better way, we will have our halogen this way. In more better reaction, we will have just one of these replaced. So you have HX, alright? HX, okay? So this is a more balanced equation, okay? Alright, so this is called substitution reaction, take note. And substitution reaction can only be undergo or carried out by alkanes, alright? So only alkanes undergo substitution reaction. I hope you understand the explanation here. So let's go to the next question. The next question says, 1 mole of a hydrocarbon contains 8 grams of hydrogen, alright? If the relative molecular mass is 92, the hydrocarbon is, so we are also looking at what hydrocarbon is that, okay? So 1 mole has hydrogen as 8. Now listen, if 1 mole of a substance has 8 grams of hydrogen, and you know, 1 atom of hydrogen is 1 gram. So that means in that 1 mole we have 8 atoms of hydrogen. Okay, so atom, the number of hydrogen in that molecule is what? 8. So the molar mass of the molecule is 96. Can you see that? 96, okay? So now we have that the molar mass is 96. Sorry, 92 I mean. Okay, 92 here. So when you remove your hydrogen, how many remain? That would be what? 84, right? Good. So what now? This 84 gram per mole is the number of, now because of the word hydrocarbon. Hydrocarbon means hydrogen and carbon. It means that the 84 gram per mole is only the mass of the remaining carbon. Remember, it's hydrocarbon. So you remove 8 grams for hydrogen. So the remaining one is for carbon. Okay, so 84 grams per mole. And you know, 1 mole of carbon, one atom of carbon is 12 grams per mole, right? So 84 means that it has how many carbons? That's what 84 divided by 12. That's what, like, that would be like 7. Okay, so the general molecular formula of that molecule that has like 2 grams per mole is C7H8. And you see that C7H8. And what can you see here? Now, you see C7H8. What formula does it conform to? Does it conform to CnH2n plus 2 or CnH2n or CnH2n minus 2? It doesn't conform to any of these formulas. Look at it. Look at the number of n. N times 2. That is what? 14. 14 minus 2 will not give you 8. You can see it doesn't conform to any of these formulas when you put the value of n. Okay? So what you do is, remember that this is C7, right? C7. It could be an alkyne or alkene, right? But based on this JAMB question, what you just, apply, some of the, the best option that could possibly be the answer. So what's the best option? Now all we need to do is C6, into the C6 and H6. That is benzene, right? So we'll try to form an attachment. Alright, so benzene having an attachment, it means that one hydrogen has to give way for benzene to be attached. Alright, it's something I wanted to solve before. So now, one hydrogen has to give way for an attachment, and alkene group to be attached to this benzene, right? So if one hydrogen gives way, it means that how many hydrogen is remaining? 3, right? How many carbon is remaining? 1, because this is 7 and this is 6. So remaining 1 carbon, how many hydrogen? 3 hydrogen. So this is the attachment. Can you see? So the compound is C6H5, then the attachment to it is what? CH3. Now this CH3 is an attachment to that benzene. So as long as you have benzene and an attachment, alright, that is an aromatic. It's an aromatic. Benzene and benzene-like compounds, they are all aromatic hydrocarbons, okay? So this is aromatic hydrocarbon. This is methyl benzene, okay? So what option is correct? Now, the option that is correct is aromatic, option A, okay? Can you see that? Option A is the most appropriate option, okay? So let's try and solve number 6. Alright, let me still wipe the board off so that we can have space to solve number 6 now. So our number 6 says, the combustion of methane is represented in the equation. So combustion of methane, CH4, alright, plus 2O2, are you there? For reaction to C2 plus 2H2O. Now that's the question. What amount of oxygen will be required for the complete combustion of 5 mole of methane? So this is 1 mole of methane, right? 1 mole of methane requires 2 mole of oxygen to have a complete combustion. So if 1 mole requires 2 mole of oxygen, right? 1 mole requires 2 mole of oxygen, then 5 mole requires what? X. So X is what? 2 times X times 1 is X. Then 5 times 2, that's 10. I hope you understand. So 10 mole. So to burn 5 mole of methane completely, we need what? 10, 10 mole of oxygen. Anything that 10 mole of oxygen. I hope you understand that, right? Okay? So let's try and solve the remaining 4 questions. Now, number 7. Most of the fatal explosions in coal mines are caused by. Now, this question is one question I know that will, will repeat itself. Alright? So, that question is, what is the cause of explosion in coal mine? Alright? During those days when the energy supply is heavily dependent on coal, alright, there's often or sometimes explosion in coal mine, and the result is because of what we call methane. Now, why does methane? One of the reasons why methane causes explosion is because methane is an odorless gas, okay? And number 2 is odorless. Number 2, methane can be synthesized in a match environment. Match ground, meaning when you have grasses, all these decaying components of plants. So when plants decay for a while, alright, they synthesize methane on their own. Okay, so in a coal mine, you have all this, environment, right, where they are mining coal, alright, and coal, is one of the raw materials that could give our methane, okay. So if methane is released in the environment, nobody knows, and any spark in that environment will lead to explosion. That's just what the basic idea. Alright, so now most of the fatal explosions in coal mine are caused by what? Methane. That is the answer. Alright, I just explained a little thing about that. Now, the next one. Which of the following compound is not a product of action of chlorine or methane in sunlight? Methane reacts with chlorine in a chain reaction, okay? Methane reacts with chlorine in a chain reaction in the presence of sunlight. Alright, either sunlight or say UV light, okay? So the first chain reaction is that one atom of hydrogen will be displaced by one atom of chlorine. So we have, alright, plus what? HCl. Can you see that? HCl, right? And the next one, C3. So C3, CH3, Cl plus Cl2 will give you what? CH2. The next one atom of hydrogen again will be displaced by chlorine, okay? Now, what would that give you? Cl2 plus HCl, alright? Now, what can you see now? You can see this is a chain reaction, it continues till all the hydrogen atoms are displaced. So the next one is CH2Cl2 plus chlorine again. One atom of hydrogen will be displaced again. So what will you have? You have what? CH. Now, how many atoms is here? 2. So the next one is just 1. So Cl3 plus HCl, and it continues to the last one. Alright? So the last one was C. Now, no more hydrogen, okay? No more hydrogen. So we have CCl4 plus HCl. This is the end product of the chain reaction. So 1, 2, 3, 4 is the chain continuous reaction in the presence of sunlight. Alright? And all these byproducts have their own uses, okay? They all have their uses. And one of the common uses that they are used as organic solvent, okay? They are all organic solvents, alright? So now, look at this. In all these options, which of them is not there? Now, this one is part of it. Now, the names are, you have monochloromethane, dichloromethane, trichloromethane, can you see mono, di, and tri, then tetrachloromethane. This compound is tetrachloromethane. Take note. Tetrachloromethane. Please take note of that. Alright? Okay? So now, let's go to the next one. The next one, the product of the reaction between ethane and chlorine is, so what will be the product of the reaction between ethane, alright, ethane, can you see that? Ethane and chlorine. So let's see. So when you have ethene, CH, okay, let me write the word ethene like this, right? Now CH2 is, remember the formula is Cn, H2N, right? Alkene family. So that is 2 times 2, that will be 4. CH2 H4, right? Now this is the structure. You need the structure in order to understand what is happening. Alright? Now when ethene reacts with chlorine, all the first one is substitution reaction, is a substitution. But in this case, nothing is being substituted. We have a double bond here that needs to be, saturated. There's a double bond here that needs to be saturated. So what will happen is that chlorine or bromine or any other halidine will go and saturate this, okay? So you now have your, if it is chlorine, you have your chlorine here and chlorine there, okay? This other place is hydrogen, this other place is what? Hydrogen. So you have hydrogen here, hydrogen there. So this double bond will split like this, alright? And form this saturated, this is a saturated compound, and this is not saturated. So this unsaturated compound, when it goes into reaction, it tends to be saturated. You understand me? So that is why the bond will form something like this. And what is the name of this? This is chlorine is there at the first carbon and chlorine is at the second carbon. So this is 1, 2, alright, chloro, ethane, not in again. This in is for double bond. As long as there is no more double bond here, it is now in, okay? Chloroethane. You understand that now, right? Let's answer the next question. So what's the answer? The next option is what? Chloroethane. That's option A. This is our correct answer. Okay? So I think the last question now. So one of the things you can do is that, you can pause the video from the beginning and, try and solve it on your own before you go through the explanation. You understand? Pause the video, try and solve it on your own before you go through my explanation. Okay? That will help you understand it. So now the last one said, this compound CH3, OH, minus H2O. This is CH3, CH, double bond CH. Now, the reagent that can be used to carry out this conversion above is, now what kind of conversion is this? Now this is alkanol, alright? 1, 2, 3, propanol. Propanol is reduced to what? Propane, and this is double bond. Propane, propanol, alkanol, let me use the word, alkanol reduced to alkane, alright? That will happen when water is reduced. So when water is removed from this, alright? Now, what will be used to extract that water, alright? What will be used to extract that water? This cannot happen with this option, ammonium silver nitrate, hydrogen in the presence of nickel. No, we use hydrogen in the presence of nickel when we want to hydrogenate. That is, you want to add hydrogen to an organic compound, right? And one of the reasons why you add is to what? To saturate the compound. You understand what I'm saying? Now, hot concentrated H2SO4. Yes, we use hot concentrated H2SO4 to perform this kind of reaction. So, hot concentrated H2SO4 is the correct answer to this. Thank you. Share this video to your friends and I hope you enjoy the class. Pause the video and start on again to master what we have discussed so far. Thank you. This is Mr. Brain.